You talk about data rate, and I know that's a big focus of the especially the invasive implanted BCIs. Why is that important? Let's dive into that and help understand what that really means.
So the currency of information in the brain is individual neurons firing action potentials.
Yeah.
And so the more neurons you can talk to and the ability to resolve these single neuron signals means that you can get the most out. The more neurons you talk to, the more data you have. And what we have is basically like an early internet situation where there are things that we can do right now with the number of electrodes you could have in clinical trials. With older devices, you can control a cursor. There are competitive platforms to Paradromics that are basically buttons that you can press like once per second. And so like those platforms tap out in what they can do. Yeah. And now like Neuralink system, let's say, is in benchmark, the highest information transfer rate that they've ever reported is 10 bits per second. So everything you've seen in the videos is at 10 bits per second. We've separately benchmarked our systems in cheap in other sort of tasks, which has a bunch of asterisks. And we're going to publish something later this month about this. But we're far above 100 bits per second, somewhere between 150 and 200 bits per second right now.
A lot of bits.
And so like that is enough. We've shown that the hardware has enough headway to do more advanced things. What does more advanced mean? Like our conversation that we're having right now, if we took a transcript and we played the transcript out at the rate that we're talking, it's about 40 bits per second. If you want to layer on emotion and sort of a little bit of texture to the conversation, it's more. You can think about applications and you can think about how much data do I need, to control various things and do various things. And then you can start to look at it in the context of your brain implants and say like, on first principles, does our brain implant support that application? And then as each brain implant gets better and better, then the application space of what you can do gets bigger and bigger. And it becomes like the early internet, where you have what the internet did in the late 80s, early 90s, what the internet did in the 2000s, what it did in the 2010s. And when you track it, you're like, oh, wow, that was a really cool pivot that Netflix made in 2010 to stream real-time video. But it wasn't because it was a genius idea. It was just that enough people had enough data at that time to make that application work. And so the history of the internet is a history of expanding internet infrastructure and hardware.
Bandwidth. So we're in the dial-up days and we're going to progress into gigabit and beyond.
Yeah, I would say I don't see any reason why we couldn't increase the data rate of BCIs by 10-fold in the next coming years and 100-fold without making huge architectural changes to the way that I would say the two leading BCI companies from a data perspective, Paradromics and Neuralink, have been operating.
Yeah.
We were really focused on building the right system. And what we defined as right system was high data rate, high longevity.